I use the latest technology to teach AI how to understand emotion in music. I like making music, but I'm not a trained musician. I'm a developer who got hooked on music production about 18 months ago. I started with Suno, the AI music generator, but it never gave me what I actually wanted. The output always felt generic. I couldn't shape it and I couldn't learn from it. So I moved to BandLab. It has MIDI instruments, samples, and I did my own arrangements. And that's where I started learning real craft. I didn't want AI to make music for me. Suno already proved that doesn't work, at least not for me. I wanted to make my own music and get better at it. Over those 18 months, I did what everyone does. I watched a million videos on YouTube on how to make music. I kept notes on everything I figured out. What makes a minor second feel like anxiety? Why a pedal steel bleeds emotion after a vocal line? When a modulation is earned versus when it's cheap? I wrote it all down in a document I call the musician's cookbook. And sometimes that knowledge was enough, like that piano intro, I could figure out I knew what I wanted, I could hear where it needed to go, and I had the tools to get there. But sometimes the music just wasn't right, and I couldn't name why. This is a Latin pop intro I was working on. The drums were right, the percussion felt good, the transitions landed, but the bass and the leads were just kind of washing out. I could hear the problem, but I couldn't articulate the fix. And if I can't identify it, I can't search for it, so I can't fix it. That's the gap. I didn't need an AI to write the fix for me. I needed one that could listen to what I made, pull the right knowledge, and explain what was going wrong and why, so I could fix it myself and actually learn something. So I built a music teacher. So here's the app. It's a chatbot style interface. I upload a beat and it does two things at once. It analyzes the audio quantitatively and qualitatively. It tells me what it hears. Then I can ask it questions in plain language. So I upload that Latin pop intro that I played earlier. I prompt with my actual issue. The drums and percussion feel right, but the bass and leads are washing out. What's going wrong? It doesn't give me a generic answer. And it doesn't try to generate music for me. It analyzes what's happening in the audio, pulls the relevant rules from my cookbook, and explains why the problem is occurring. It gives me two or three suggestions, each one grounded in a specific concept, with an explanation of why that approach works. I'm the one who makes the changes. The app is the teacher. I'm the student. And here's what that sounds like after I apply the changes. And here's that same section in the finished song. That's a quick demo of how the app functions. Now let me show you how it actually works under the hood. Here's the thing. If I ask ChatGPT, why is my bass washing out my leads? I'll get a decent answer about frequency masking or EQ. That doesn't tell me a fix that can be applied to my music. It tells me a symptom. But my cookbook has a hierarchy rule that says the later melody must remain emotionally primary. And if the counter melody sits in the same octave band, you get frequency masking and emotional confusion. It even has a section that says you tend to overbuild because I do. That's not theory, that's craft. It's my craft, and no LLM has it in its training data. Without my cookbook, the app would just give generic music theory answers. With it, the app can explain why my specific arrangement has a problem using my own framework and teach me how to think about the fix. It doesn't write the music, it makes me a better musician. So the question becomes, how do you get the right pieces of that cookbook into the model's context at the right time? That's where the architecture starts. This is the part most people haven't heard of, and it's honestly the most interesting piece of the whole system. A cookbook is about 1,700 lines. It has chapters that cross-reference each other. A cadence rule depends on what the melodic contour is doing, which depends on the instrument's register, which ties back to the emotional interval. If you just chop it into dumb chunks, you shred those relationships. Let me show you what the data looks like. Each chunk from the cookbook has a content string, that's the actual rule with its emotional effect, and when to use it, plus rich metadata like what chapter it belongs to, what emotions it targets, how relevant it is to tension. 58 chunks across 7 chapters are all structured like this. Here's the key insight. Instead of embedding each chunk by itself, I group them by chapter. I then pass each chapter as a batch to MongoDB's Voyage AI's contextualized embed function. This means chunks within the same chapter, say 3 different cadence rules, get embeddings that are aware of their siblings. The deceptive cadence embedding knows the authentic cadence exists nearby. That context makes the embeddings dramatically better for retrieval than embedding each chunk in isolation. One detail most tutorials skip: when you embed at search time, you use the same model but switch the input type to query. At ingestion, it's document, and at search, it's query. This asymmetry is how the model knows it's matching a question against stored knowledge rather than comparing 2 documents. Small flag in the code, but big difference in retrieval quality. But here's why I couldn't just use semantic search alone. My cookbook is full of music notation mixed with natural language, something like fifth major to sixth minor progression. Embeddings might understand the intent behind a question about that, but they can miss the exact notation. So I built a hybrid search pipeline. Vector search, powered by Voyage AI embeddings in MongoDB Atlas, handles the semantic side. Lexical search handles exact matches. I weight semantic 2-to-1 over lexical and merge them using reciprocal rank fusion. Best of both worlds. After hybrid search returns about 20 candidates, MongoDB's Voyage AI's re-rank 2 model does a deeper pass. The code is clean. 3 steps: extract the content strings, call vo.rerank with the query and documents, then map results back to the original chunks using the index property. It narrows 20 candidates down to the top 5 most relevant. Those 5 are what the reasoning model actually sees. And here's how it all connects. Retrieve 20 candidates via hybrid search, then re-rank to the top 5 via Voyage AI, then format them for the prompt, and finally track the chunk IDs for provenance. That's the whole retrieval pipeline. And if the re-ranker goes down, the system just uses the fusion ranked order. Graceful degradation. Nothing breaks. When I upload a music clip, 2 things happen in parallel. Librosa extracts the numbers, BPM, spectral brightness, onset density. These are quantitative features. They're precise, but they can't tell you a beat feels dark and introspective, or that the groove has a syncopated dembo pattern. Then Google Gemini comes in. I send the actual audio file to Gemini, and it returns a structured analysis. Instruments detected, groove type, emotional tone, energy arc, implied harmony, production style tags. It's the subjective ear that numbers alone can't provide. Together they give the reasoning model a complete picture. While Librosa says the spectral centroid is low and onset density is moderate, Gemini says it sounds like a laid-back Latin pop groove with warm 808s, and the energy builds through the percussion. Both feed into every recommendation, and if Gemini is unavailable, the system falls back to Librosa only. The experience is less rich, but nothing breaks. That's a pattern you'll notice. Every service in this system has a fallback. You already know OpenAI, so I'll keep this short. 2 models split the work. GPT-4o Mini does lightweight intent parsing. It figures out what you're actually asking about before the search even runs. Then GPT-4o is the main reasoning engine. It receives everything: the retrieved cookbook chunks from Voyage AI, the combined audio analysis from Gemini and Librosa, the lyrics, the intent, and the last 6 messages of conversation. And finally, it's running under a constitutional system prompt that enforces 14 interaction rules, things like it can't generate music and it can't write an arrangement. It stays in its lane as a teacher. It analyzes, explains, and suggests. I do the creating. The output is structured JSON, a message, 2 to 3 constrained options with explanations and source chunk IDs, so you can always trace where the advice came from. A few things worth calling out: the entire RAG pipeline is custom, no LangChain. So retrieval, re-ranking, prompt construction, fallback logic, all hand-rolled. When something breaks, I know exactly where to look. Every AI service degrades gracefully. Gemini down, then Librosa only. Voyage AI re-ranker down, then fusion order. OpenAI down, the engine features still work. No single failure takes down the system. Every LLM call logs the model, task type, tokens, and latency to MongoDB. I can see exactly what each interaction costs. And all AI calls are back-end only. No API keys ever touch the front end. I built this because I needed it. I'm a music maker who can hear when something's wrong, but can't always name why. I didn't want AI to make music for me. I tried that, and it doesn't teach you anything. I wanted a tool that could listen to what I made, search my own knowledge base, and explain what's happening and why, so I could learn, so I could get better. That's what this is. If you're building AI tools, the biggest thing I took away is this: don't make one model do everything. Split the work by what each service is actually good at. Build fallbacks into every layer and track your costs from day one. If you want a deeper dive on any piece of this, drop a comment. Thanks for watching.